Hello everyone, I'm Dr. Buddhika Liyanike. So today's topic is chemistry of baking a cake. There are a series of chemical reactions and physical changes during this baking process. Let's go and find out the chemistry behind this baking a cake. Baking a cake is a complex chemical process that involves multiple reactions and physical changes. Ingredients and their roles. We use flour, sugar, eggs, oil, and different ingredients. Let's see what are their roles. The flour contains proteins. There are two types of proteins, gluten and gliadin. And in addition to the proteins, flour contains starch. So what is gluten formation? Gluten formation is when flour mixes with water, these two proteins, gluten and gliadin, form gluten, which provides structure and the elasticity to the dough. Sugar. Sugar we are adding for sweetness to the cake or any baking goods. That affects texture and the moisture retention. And in addition to that, caramelization. During the baking process, sugar undergoes caramelization that contributing to flavor and the browning. Eggs. Eggs provide the structure, moisture and the fat. The proteins in the eggs coagulate when heated. This coagulation helping to set the structure. And the most important thing is emulsification. The emulsification is a process of mixing two immiscible phases together. So egg yolks, the lecithin in egg yolks helps to mix fats in water, doing this emulsification reaction. Butter or oil adds moisture and the richness. Butter can create a tender crumbs while oil can make the cake moist. The leavening agents, baking soda and baking powder. They produce carbon dioxide gas. That carbon dioxide gas causes the cake to rise. Baking soda, chemical name is sodium bicarbonate, reacts with acidic ingredients to release carbon dioxide. However, baking powder contains both acid and the basic components, and it releases carbon dioxide when it moistens and heated. And it releases carbon dioxide when it combined with wet ingredients and heated. Liquids, milk or water, that hydrates the flour and the dissolving sugar and the salt, and it activates baking powder and the baking soda. It provides steam which helps the cake rise and stay moist. The sweet science, chemical reactions in baking. Before the baking process, mixing flour with wet ingredients, and then there are two reactions taking place, gluten formation and starch gelatinization. When we mix butter or oil with eggs, it forms emulsification. During the baking process, there are series of reactions. Maillard reactions, egg coagulation, caramelization, and leavening agents release carbon dioxide. And after the baking process, set the structure completely and flavor melts. So let's talk about each of these reactions in next slides. What are the key chemical reactions and the physical changes during the baking process? Mixing and emulsification. Hydration. When liquids are mixed with dry ingredients, flour proteins, gluten and gliadin, that hydrates and start forming gluten. Emulsification. Eggs, especially egg yolks, act as emulsifiers. The lecithin in egg yolks helping to distribute fat evenly throughout the batter. This creates a uniform texture. The leavening agents, baking soda and the baking powder. Baking soda, sodium bicarbonate, NaHCO3. When an acidic ingredient is present, baking soda reacts to produce carbon dioxide gas, which helps to cake rise. Baking powder contains both an acid and the base. When mixed with wet ingredients, it undergoes two stages of reaction, one at room temperature and one at the baking process. They produce carbon dioxide gas. These acids commonly used in baking soda are cream of tartar or monocalcium phosphate. Gluten formation. Gliadin and the glutenin are two types of proteins in wheat flour. When they mix with water, they form gluten. In gluten, gliadins and glutenin are connected by interchain disulfide bonds. Due to presence of these disulfide bonds, they provide unique viscoelastic properties to the gluten. The disulfide bonds formed in between amino acids. For example, cysteine is a sulfur-containing amino acid. So these cysteine amino acids form interchain disulfide bonds that contributes to the unique viscoelastic properties to the gluten. Key factors affecting the gluten formation. Flour type. The different types of flour have the varying amounts of glutenin and the gliadin. For example, bread flour has a high protein content than the cake flour, so resulting in more gluten formation. Water content. The amount of water added affects on the hydration of these two proteins. Too little water and the proteins won't hydrate properly. So if we add too much water, can weaken the gluten network. Kneading time. The proper kneading is essential to develop the gluten network. Insufficient kneading results in weak network, while the over-kneading can break down the gluten structure. Resting time. Allowing the dough to rest, also known as autolyse, can help improve the gluten development. So understanding this chemistry behind the gluten formation is crucial for achieving the desired texture and the structure to baking goods. The key chemical reactions in addition to the gluten formation. The Maillard reaction and the coagulation and the gelatinization. In the Maillard reaction occurs between amino acids and reducing sugars at higher temperature that leads to browning and the flavor development. Caramelization. Sugars undergo the thermal decomposition when heated that produce flavors and the brown color. In the coagulation process, egg proteins. As the cake heats, the egg proteins denature and coagulate, that helping to set the structure. Starch gelatinization. Starch granules absorb water and swell, that thickening the batter and providing the structure upon cooling. We can say this is lecithin present in egg yolk. The lecithin is a group of yellow to brownish fatty substance that occur in animals and the plant tissues. This is amphiphilic. Amphiphilic meaning is they attract both the water and the fatty substances. Then they provide the smoothing food textures, emulsifying, homogenizing liquid mixtures. What is the baking process? The baking process requires to preheat the oven that ensure the cake starts baking at the correct temperature. During the baking process expansion, as the batter heats, gases from leavening agents expand, causing the cake to rise. Setting the structure, proteins coagulate at high temperature and starch gelatinizes, solidifying the cake structure. Browning, the Maillard reaction and caramelization contributes to the crust color and the flavor. After the baking process, the cooling, the cake sets completely and flavor melts as it cools. The chemistry behind baking a cake involves a complex interplay of physical and the chemical changes. The leavening agent produces gases, gluten forms a network to trap gases, and heat causes proteins to coagulate and starch to gelatinize, setting the cake structure. Browning reactions add flavor and the color, resulting in delicious and well-textured cake. Understanding these processes can help bakers to achieve better results and troubleshoot any issues that arise during baking process. Happy baking!